friends, welcome back to another Alpha Notes video. Today we're going to be learning about the law of sines and how we can apply it when we are solving for the unknown measurements of a triangle. Like the law of cosines, the law of sines allows you to solve for an unknown measurement as long as you have the three other appropriate measurements from that same triangle. This is what the law of sines says. The sine of A divided by A equals the sine of B divided by B equals the sine of C divided by C. Usually you will only have two fractions in the equation, one on each side of the equal sign, and you will solve by doing cross multiplication. Let's solve some problems now. So in this problem, we need to find the length of B. So all that we need to do is plug in our known values into the equation. So it's going to say that the sine of A, which is 25, divided by A, which is 14, is going to equal the sine of our B, which is 75, divided by B. Now we need to cross multiply and enter these values into our calculator. So the sine of 25 times B equals the sine of 75 times 14. So B equals the sine of 75 times 14 divided by the sine of 25. We are going to enter this equation into our calculator, and our answer comes out to B equaling 32. So 32 is our final answer. So in this problem, we are going to have two equations. First, we need to solve for angle A since we have the length of that side. So the sine of 125 divided by 6.4, these are our two C values, is going to equal the sine of A divided by 4.0. We are going to cross multiply and see that the sine of 125 times 4.0 equals the sine of A times 6.4. We will divide both sides by 6.4, and our final answer is that the sine of A equals 30.7. Now let's use logic. Since we know that there are 180 degrees in a triangle, we can do 180 minus 125 plus 30.7. We are getting 125 from our angle C, and we're getting 30.7 from our angle A. Add these two together and subtract from the entire measurement in a triangle, and this will leave us with the measurement of the remaining angle. So we know that the sine of B, which is our remaining angle, is going to be 24.2. For these next types of problems, we are not going to use a calculator or a table. The directions tell us to find the exact value of A over B in triangles ABC. Remember that A over B can be written as the sine of A over the sine of B. We already have the value of sine over A, so all that we need to do is find the value of the sine of B. We can use the Pythagorean identity, which says that the sine squared of an angle plus the cosine squared of that same angle equals 1. So we can transform this equation so that it equals the sine squared of B. Sine squared of B equals 1 minus 4 divided by 5, which is our cosine, squared. The 4 over 5 replaces the cosine of B squared, which we are given in the problem. The difference of this equals 9 over 25. But we need to take the square root of this, so our answer is going to equal 3 over 5. Now all that is left is to substitute this back into our first equation, where our directions tell us to write A over B as sine of A over the sine of B. So we know the sine of A is 2 over 3 divided by the sine of B, which is 3 over 5. This also equals 2 over 3 times the reciprocal of the denominator, which is 5 over 3. This equals 10 over 9. So 10 over 9 is our final answer. Let's try one more problem like this. This problem says that the cosine of A equals 5 over 13 and the cosine of B equals 3 over 5. So the problem here only gives us the values in cosine, not sine, so we need to do the process that we did earlier twice. One for A and the other for B. Let's start with the A. So the sine of A squared equals 1 minus the cosine of A squared, which is going to be 5 over 13 squared. The difference is 144 over 169. However, we need to take the square root of this, so our final answer is going to equal 12 over 13. This is for the sine of A. Now we need to find the sine of B. We will repeat the same process. So the sine of B squared equals 1 minus 3 over 5 squared. This equals 16 over 25, which you will take the square root of and translates to 4 over 5. Now we need to go back to the beginning of our problem where it asks us to do the sine of A divided by the sine of B. Our sine of A is 12 over 13, so we're going to do 12 over 13 divided by 4 over 5. This also translates to 12 over 13 multiplied by 5 over 4. 12 times 5 is 60, and 13 times 4 is 52. We can simplify this fraction to 15 over 13. So our final answer for this problem is 15 over 13. Now let's solve some word problems which involve the law of sines. The first word problem says this: how long is the base of an isosceles triangle if each leg is 27 centimeters and each base angle measures 23 degrees? Let's draw a model. By looking at the model, we can see that the 23 angle corresponds with the 27 centimeter side. Since we know that there are 180 degrees in a triangle, we can do simple math to find out that the remaining angle up here is 134 degrees. Remember that this model isn't drawn to scale. Now that we know the three measurements of this triangle, we can put it into an equation. So the sine of 23, which would, for instance, be angle A across from side A, divided by 27, is going to equal the sine of 134 divided by x. X is the length that we are trying to find, which is the base. If we cross multiply, our answer will come out to 49.7. Now let's solve our final problem. This is what the problem says. A loading ramp 5 meters long makes a 25-degree angle with a level ground beneath it. The ramp is replaced by another ramp, which is 15 meters long. Find the angle that the new ramp makes with the ground. Let's start off by drawing a model. So we are told that a loading ramp, which is 5 meters long, makes a 25-degree angle with the level ground beneath it. This ramp here is replaced with another ramp, which is 15 meters long. We are asked to find the angle that the new ramp makes with the ground. Something that never changes and is constant in both of these is the height of this side in the triangle. We know that the length of the ramp corresponds with a 90-degree angle, so we can use our law of sines to solve for this. However, first we need to know the height of this side. So the sine of 90, created in the 90-degree angle, divided by 5, is going to equal the sine of 25 divided by x, which is the height right here. After cross multiplication, we can see that the shortest side in the triangle, or x, is going to equal 2.11 meters. So we know in this triangle, the length here is 2.11 meters. Now we have 3 known sides of this triangle and 1 unknown side which we are trying to find. So we can say that the sine of 90 divided by 15 this time is going to equal the sine of our unknown angle divided by 2.11. X is the measurement of our unknown angle, which is the opposite of the side that is 2.11 meters long. We can now do cross multiplication and we will find that the measurement of the unknown angle equals 8.1 degrees approximately. So the new ramp makes an 8.1 degree angle with the ground. Thank you so much for joining me for another video. I hope that you learned a lot about the law of sines, and I can't wait to see you in the next video.